In this video, we're going to introduce the gradient-intercept formula of a line. And it's in the form y equals mx plus c. Now the c represents the y-intercept, so that's the point where the line intersects with the y-axis. The m represents the gradient. The x represents the x-coordinate of some point, and the y is the y-coordinate of a point. So in other words, if you pick any random point, as long as it's on the line, so let's say we pick a point there on this line, if we substitute in the x coordinate, okay, so that's the coordinate x comma y. So if we take the x coordinate, substitute it into the formula, given that we know the gradient, which is obviously the tilt of the line, substitute into the formula, add the y-intercept, we can then calculate the y-coordinate of that point. So this is what we call the dependent variable. X is the independent variable. So given x, we can calculate y. So let's have a look at an example. Oh, there's a couple of examples actually we'll look at. So example 1, find the equation of the line with gradient -2/3 and passing through 0, -4. So the gradient intercept formula, y equals mx plus c. So won't need hopefully too much space for this. Okay, and this is the basic. I think this is probably one of the most useful formulas. In fact, the foundation of the topic of coordinate geometry really is based on this one equation, and we can do so much with that. Do we know the gradient m? Yes, it is. It's given. It's -2/3. Now, passing through, the line passes through 0, -4. Okay, so the y-intercept, in fact, has a x-coordinate of 0. In fact, that's the equation of the y-axis, isn't it? Okay, so any dot or any point on the y-axis will have an x-coordinate of 0. So you should recognize this really as the y-intercept. Okay, and as long as you can see that, we could just write the formula. So this is really y equals -2/3. So gradient x. Okay, so -2/3 times x. Now it's plus c, but the c happens to be a -4, so it's just -4. And that's it. Very simple. Let's have a look at another a little bit more elaborate example. So find the equation of a line passing through -1, 7 and 3, 2 in gradient intercept form. So I think what we might do, just to sort of help you visualize this a little bit, why don't we draw it? Okay, so it doesn't have to be a very accurate sketch. As long as it's reasonably accurate, you can just draw a quick sketch of a coordinate plane. So x, y. There's the y-intercept there. X, y there. Now -1, 7. So -1, 7 is probably up here. In fact, just to make it a little bit easier, why don't I label these points? So this is point A. Okay. And point B, 3, 2, so 3, 2, doesn't have to be to scale. As long as you get the points in the correct quadrants and relative to each other, the y coordinate of B is 2. A, it's 7, so B is going to be quite a lot lower than A in terms of just sort of where they're positioned, those 2 points. So we can see immediately that if I was to draw a line through those 2 points, the gradient's going to be negative, isn't it? So that's sort of, I guess, the first thing to notice. And it's actually a really good starting point when you're sort of asked to find the equation of any line. Maybe think to yourself, well, what's probably an easy thing to find? A line has 2 characteristics. It's got a gradient and has a y-intercept, unless it's a perfectly vertical line, in case that's a sort of a special case. But as long as it's not a vertical line, it's going to have those 2 things. Okay, so let's find the gradient first of all. Okay, so let's just a different color pen. So first of all, let's start off with the form of the equation that I want in the end. This is what we're going to sort of end up with. We need to find the m. Okay, so that's really our question mark. We also need to find the y-intercept, which is obviously here, right? There's our plus c. Okay, and I think given that the 2 points are in quadrant 1 here for point B and quadrant 2 for point A, we're going to expect a positive plus c. Let's find the gradient first, and we can use the 2-point formula for that. So if you can sort of visualize your right angle triangle there. Okay, m is equal to y2 minus y1 over x2 minus x1. Okay, so look, I guess the convention here is that the right-hand point, you make that x2, y2. You don't have to, but it does make it a little bit easier just to visualize, at least for now. I'm going to make the left-hand point, this is x1, y1. Just for the purposes of calculating the gradient. If I switch those two around, it doesn't really matter. I'm going to get the same answer anyway. Okay, so y2 minus y1, so it's going to be 2. Okay, so 2, actually I'll do it up here, 2 minus 7. Okay, so I'll just put the coordinates here as well. So this is negative 1 comma 7. Yep. Okay, so 2 minus 7 over, okay, x2 minus x1. So 3 minus minus 1. Okay, so minus negative 1, and 2 minus 7 is equal to negative 5. 3 plus 1, so double negatives make it positive. It's going to equal 4. So gradient's negative 5 on 4. All right, so we've now found one thing. So hence, y is equal to mx plus c. We have the m, negative 5 on 4x plus c. So that still leaves us though with the y-intercept. That's all we need to find now. We can use any point. Now to find the plus c, we can use any of the points that's on the line, substitute it into this equation for x and y, of course, rearrange the formula, and then find our y-intercept, and then we can basically come up with the equation in gradient-intercept form. Okay, so let's pick the point B. It's sort of nice to use numbers that are all positive. It's a little bit easier, I guess. So when x is equal to 3, okay, y is equal to 2. If I substitute those two values into our equation, let's call this sort of equation 1, just into our sort of our equation there. Let me just make it a little bit neater. So, yep. So I'm going to substitute these 2 points into this equation, and we're going to find the plus c. So y is equal to 2 is equal to negative 5 on 4 multiplied by x, so x is 3, plus c. Let's rearrange this formula now. So 2, now this is negative 5 on 4 times 3. And in fact, just before I rearrange it, let me just multiply them together. So negative 5 on 4 times 3 is negative 15 on 4 plus c. Now I think we can rearrange it, add 15 on 4 to the other side is equal to c. Okay, and so hence c is equal to, and we can just leave it in I guess improper fraction form. That's 2 is 8 on 4, so 8 plus 15 is 23 on 4. Okay, therefore the equation of the line is y equals, okay, now we've got the gradient already, so negative 5 over 4x, and we now have our plus c, plus 23 over 4, okay, and this is our final answer. Now what I like to do, if you're asked to graph this as well, just make sure you write this equation sort of somewhere near the line as well. So just to sort of, for completeness, I would write the equation here, y, if I can fit it. This is only if you're asked to graph it, plus 23 over 4, and this will be our 23 over 4 here. Okay, so that'll be our y-intercept.